Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmadani Imran bin Amirul Nizam, and today I want to present about application of vector in playing baseball. So first of all, the introduction. In mathematics, a vector quantity that lacks position but has both magnitude and direction. A vector can be conceptualized geometrically as a direction line segment with an arrow pointing in direction and length equal to the vector's magnitude. So the vector points from its tail towards its head. Due to the fact that many physical quantities can also be expressed as a vector, the concept of vectors is crucial to understand physics. Vector include, for instance, force, velocity, and acceleration. Vectors are used extensively and fundamentally in many different areas. Vectors are useful tools in many fields, including computer science, mathematics, physics, and engineering. For describing values with both magnitude and direction, they are essential for problem solving because of their adaptability and usefulness, which allow the examination of motion, force, electromagnetic field, geometric shapes, data, and more. Vectors are essential to modern science and technology because they drive innovation and knowledge advancement across a wide range of fields. So we will start the application of vector in playing baseball. So in baseball, professional pitchers, which the people that pitch the ball to the batter, possess the ability to throw a wide variety of pitches, including curveball, forkballs, and fastballs. Every kind of pitch has a different unique flight path. So there are three factors that affect a pitcher's ball's motion, which are gravity force, air resistance, induced drag force, and lift force, which causes a ball to deflect laterally or vertically due to the Magnus force. So in technical term, spinning baseball experience the Magnus force while in flight, which works in tandem with gravity to cause baseball to deviate from its intended path. Isaac Newton carried out the first experimental studies of the Magnus force. So this force, like gravity force, drag force, Magnus force, can be converted into force vector, which has magnitude, orientation, and sense. A vector's magnitude is expressed as a positive number and a unit with the proper dimension. The relationship between vector and certain reference line and plane indicate the vector orientation. The arrangement of 2 points on a line parallel to a vector indicates its sense. So this is a sense of vector, which is if the vector of one force go upward, so its y-axis is up, that's mean the vector of the force is positive. So if the force go right, which means its x component x component go to right, it means the force is positive. If the force go left, if the force vector go to left, so its unit will be negative, same as if the force is go downward. So the force vector will be negative. So the combination of orientation and sensation determines a vector's direction. So an imaginary infinite straight line that is collinear with a vector is called its line of action. So this is like this arrow is example of an imaginary infinite straight line. So this arrow can be called line of action of the force. So next we will see here, this is a baseball. So figure 1 shows that the force acting on a baseball in mid-air that is spinning. So this baseball is spinning in the mid-air. So there are a few force that exert in this spinning baseball, on this spinning baseball. So the weight of the baseball W act downward because of gravity force. The drag force Fd act in the velocity direction. So this is a velocity, and also we can call the direction of the baseball so its opposite will be the drag force because of the air resistance. So and Magnus force Fm act in the angular velocity across an angular velocity cross product with velocity of the baseball direction. So this is angular velocity, and cross product with V, we will get Fm, Magnus force. So from the vector force, we are able to find the magnitude and direction of the force from spinning baseball. we can calculate all the force for that exert in this spinning baseball, that we can determine the direction of this spinning baseball and its magnitude. So this is an example of application of vector in playing baseball. So a pitcher has thrown the ball to the batter. So the ball, which has spinning effect, as shown in figure 2. This figure 2, the weight of baseball is 1.49 Newton. The drag force FD is 20.97 Newton, and the Magnus force FM is 10.48 Newton. The ball is landed down at 30 degree, and the external force F that given to the ball is 23.84 Newton. So find the magnitude and direction of the force from the spinning baseball. So basically in this question, given W, weight of the baseball, drag, value of drag force, Magnus force, and how many degree that the ball is land down, and external force. So external force is a force that exert to the baseball, like when the pitcher throw the ball, the pitcher exert external force to the baseball, and the baseball have the velocity. The baseball have the velocity to reach the batter. So this is the solution after we redraw and label all the information given. So we got here the external force is parallel with velocity, and the opposite of external force is drag force, because of the air resistance. And as we see here, this is the angular velocity. If we cross product with velocity here, we will get Magnus force here, same as this picture. If we cross product velocity with angular velocity, we will get Magnus force. So W will act like downward because of the gravity force. So the equation of W is mg. In the equation of weight, we have gravity force and mass. We use W, weight, because this ball have mass, and this W, and we break down the W into two components, which is W with X component and Y component. So we split the weight W into two components, which is X component and Y component. So this is x component w, and the formula of x component is wx equal to w sine theta. So we substitute w with 1.49 Newton sine 30 degree, because the ball land down 30 degree. So we get 0.45 Newton. So for y component, wy equal to w cos theta. If we substitute, we will get 1.49 cos 30 degree, and we get the answer 1.29 Newton. So next, the example. Calculate. Next step is calculate total forces of each axis component. So we get here, we get the w in y axis and w in x axis. So we can calculate the force in x axis and y axis. So for y component, total of force in x axis, we got here Magnus. It add upward, so the Magnus force is positive, and downward wx act downward, so we make it negative. So after we got 10.48 Newton minus 0.745 Newton, and we got 9.735 Newton. So for the y component, we got negative FD because it act backward, and wy is forward, and f is also forward. So if we calculate, negative 20.97 plus 1.29 plus 23.84, we will get 4.16 Newton. So how to find magnitude of the, next we have to find magnitude of the vector force from spinning baseball. So we got here F equal to square root sum of fx square plus sum of fy square. So we got here sum of fx 9.735 square plus 4.16 square, and after we calculate, we will get 10.59 Newton, the magnitude of the spinning baseball. Lastly, so next, find the direction. We have to find direction of the vector force from spinning baseball. Theta equal to tan power of -1 multiplied by sum of fy over sum of fx. If we substitute the two value, tan power of -1 multiplied by 4.16 Newton over 9.735 Newton, and we will get the answer is 23.14 degree. Therefore, the spinning baseball is directing 23.14 degree above x-axis with magnitude of 10.59 Newton. So the ball, as a result, the ball will go upward 23.14 with angle 23.14 degree with magnitude of 10.59 Newton. So the conclusion, in conclusion, vectors are applied in a wide range of fields and sectors, demonstrating their versatility, their capacity to concisely convey direction and scales makes them invaluable for resolving challenging issues and expanding knowledge in a variety of disciplines. Vectors are useful and versatile tools that can be used to express value with both magnitude and direction. A foundation for comprehending the dynamic interaction between baseball players and the ball is provided by vectors. They aid in technique analysis and improvement, strategic decision making, and the improvement of hitting, pitching, and fielding performance for both player and coaches. So these are references that I use in this slide. So that's all from me. I hope this presentation is helpful, and thank you very much.